So in this, dear students, in this presentation, we are going to study about the transaction management. Transaction management in DBMS. Okay. So what is transaction? So the transaction is a unit of program execution that accesses and possibly updates various data items in the database. Okay. So it is a unit of program execution that accesses, that changes some updation is happening in various data items in the database. For transaction, we are taking this example. We are going to transfer. Okay. For this, we are taking two persons account, that is account A, account B. From account A, this account A is going to transfer $50 to account B account. Okay, this $50 amount he is going to transfer to account B. So for this, there is a short program, small program. So first we have to read A. Okay, so read A. So what is the function of read A? The read A is going to minus from his account, he is going to transfer 50 to account B. So it is going to be minus. Okay, so minus 50. Now we are going to write the output of A. Okay, so for example, A is having $100 in his account, 50 is minus, so his amount should be detected and it should be changed at 50. So now read B. Next transaction is read B. What is happening? B A is transferring account 50 to B. So amount is plus 50. Okay. So now we are write the output of B. So B is also having 100 rupees in his account. So now it is added as 150. So the two issues occurs while transfer transaction. Okay, two main issues occurs deal with this transaction. So first is the failure of various kinds, such as hardware failure and system crashes can occur during the transaction. The next is the concurrent execution of multiple transactions also can lead to an issue. Okay, so these are the two major issues in transaction management. So for this, it requires four things for transaction. For a decent transaction, it requires four things. So for everything, we are taking the same example. Okay, so first requirement is atomicity requirement. So what is atomicity? So if the during the transaction of data in step 3 before step 6, if this fails, if the transaction fails, then it leads to money lost, leading to inconsistent database states. Okay. So failures can happen due to software or hardware failure. Okay. So what is atomicity? The system should ensure that updates of partial executed transaction are not reflected in the database. Whatever transaction is happening, it must be reflected in the database. That is the atomicity. Durability. So once the user has been notified that the transaction has completed, then there must be updates in the database. Okay, even the system leads to software or hardware failures, the transaction must persist. Okay, there must be updates in the database. That is durability. The next one is the consistency. Okay, so for this also we have taken this example. Okay, so this so the same example is taken. So sum A and B is unchanged by the execution of the transaction. It leads to inconsistency. So for consistency, it mainly requires integrity constraints. It is a set of rule. It maintains the quality of the information. Integrity constraints. So it requires integrity constraints. Okay. So whatever changes we are doing, it must be updated in the database. Otherwise, it leads to inconsistency. So this is the next thing, consistency. Then okay. Transaction must see in the consistent. So transaction must see a consistent database only. Should not be inconsistent. It should not lead to confusion. Okay, that is the thing in consistency it requires. Isolation requirement. What is isolation requirement? So consider this is the transaction happening at the same. See, if between step 3 and step 6, another transaction T2 is allowed to access the partially updated database, then it leads to what? Inconsistent database. So we need an isolation. Isolation means what? After completing one transaction, then only the next transaction should happen. So concurrency is very requirement here. A concurrent transaction. That means the transaction should run serially. Okay. So in between the transaction should not happen. Once completely the database is updated, then only the next transaction must happen. So this is the 4 main important requirements of a transaction management. So next we are going to study about the ACID property. So in order to maintain this consistency, so you know what is consistency. Whatever transaction we are doing, immediately there must be an update in the database. Otherwise, it leads to confusion. So there must not be an inconsistent database. So in order to achieve a consistent database, we are going for ACID properties. So what is ACID property? So this denotes atomicity. This denotes consistency. This one isolation. This one durability. So already we have studied all this in the previous slides. Okay, so atomicity. So a good transaction needs atomicity, consistency, isolation, durability. So what is atomicity? Properly, whatever operations you are doing in the transaction, it must be properly reflected in the database. That is atomicity. What is consistency? Execution of the transaction is isolation, preserves the consistency of the database. What is isolation? There must be a concurrent transaction. Okay. Okay, once a complete updation is done in the database, the next transaction must happen. This is the isolation. What is durability? After a transaction completes successfully, the changes it has made to the database must persist even after the systems or software failure happens. So next we can study about the transaction states. The transaction states are active states, partially committed state, failure state, aborted state, and committed. So these are the various transaction states. The active state is the initial state. Okay, the transaction stays in this state while it is executing. Partially committed means after the final statement has been executed. Failed means after the discovery of a normal execution can no longer proceed. That is called as failure. Okay, aborted means after the transaction has been rolled back and the database restored to its state. Okay, then 2 options after it has been aborted, that is restart this transaction or kill the transaction. For aborting, okay, aborting the transaction. Once the transaction is completed, it is aborted. Okay, either the transaction is restarted or it is kill the transaction. These 2 things will happen. Committed, after successful completion, it goes to the committed state. So this is the transaction state. So active state, partially committed state. This partially committed state. Once the partially committed state, it can lead to failure also. Or active state, even it can go for failure state. Okay. So after partial committed state is what? Successfully transaction has completed. That is called as committed state. If failure occurs, what we will do? It will be aborted. Okay. No more extending that transaction. So these are the transaction states. Okay. Active state, partially committed. It can also lead to failure. Active states even can lead to failure. Then this is the initial state. Okay. At the initial state itself, failure can occur. Partial committed state also failure can occur. If failure occurs, then the transaction is aborted. Once the partially committed, it leads to a fully successful transaction is called as the commit. Thank you.